Good afternoon. My name is Pippa Chapman and I'm a Professor of Soil Science at the University of Leeds. In this presentation today, I'm going to discuss how soil texture and structure control water movement through soil, and then show how degradation of the soil structure can lead to enhanced runoff. Soil texture refers to the proportion of sand, silt and clay-sized particles in a soil and is controlled by parent material. Some soils contain a lot of sand-sized particles, while others are dominated by clay-sized particles. Sand particles cannot pack as close together as clay particles, so they have larger spaces or pores between the soil particles. And this means that soil texture controls the size and number of pores in a soil and the rate at which water percolates through a soil, as shown by the arrows in this diagram. Soil texture therefore controls the rate of infiltration and the water holding capacity of a soil, as shown in these figures. The triangular figure usually shows the soil textural classes, where soils dominated by clays are in the top of the triangle and the more sandy and silt soils are at the base of the triangle. Here, infiltration rates have been overlain, and it shows that the highest rates, highlighted in blues and greens, occur at the base of the triangle, where we find sandy and silt soils, and the slowest infiltration rates, shown in red and orange, are at the top of the triangle, which is dominated by clay soils. So sandy soils have higher infiltration rates, but they are unable to hold on to this water for long and so tend to be droughty. Whereas clay soils hold a lot more water, as shown in the diagram on the right, and release the water more slowly to rivers and groundwater. But soils do not just contain mineral particles, they contain soil organic matter. And this has a big impact on the water holding capacity and infiltration rate of a soil. Soil organic matter is able to absorb more water than mineral particles, and therefore for every 1% increase in soil organic matter content, there is an increase of 25,000 gallons per acre. For those that prefer metric units, that is approximately 234,000 litres per hectare. And soil organic matter also controls infiltration rates via its influence on soil structure. Soil structure also influences water movement by the arrangements of the soil aggregates. Water moves much more quickly downwards through the soil with a granular structure, as shown here on the left, compared to a soil with a plated structure where the movement is much more tenuous through the soil, as shown on the right. Structure, unlike texture, can be easily modified by human management. Soils can be compacted by heavy machinery, as shown in the figure, and livestock, and it leads to a reduction in the porosity and loss of soil structure, as shown in the figure below the photo. This reduction in soil porosity leads to lower infiltration rates and higher runoff and risk of flooding. Tillage is also a major cause of loss of soil structure and soil organic matter. So let's have a look at how cultivation has an impact on soil structure and organic matter. Here are some soil samples taken from the University of Leeds farm. We have soil samples taken from beneath hedgerows, from grassy strip margins adjacent to the hedge, and then 2 and 32 metres into an arable field. What differences do you see in the soil as we move from the hedge to the arable? You should note 2 main differences. I hope you've got them. There's a change in colour. It becomes lighter as we move from hedge into the arable, and there's a change in soil structure. The structure is more granular under the hedge, and it's more blocky in the arable soil. And this difference is related to a change in soil organic carbon content. We can see there's a 40% difference between the carbon content of the soil under the hedge to the arable field. And the arable soil has been disturbed through tillage, and this has broken down the soil aggregates, and they now stick together in much more blocky structure. And if I were to sprinkle some water onto these soil samples, we would see a difference in the infiltration rates, with them being much quicker in the soil from the hedge, and we're more likely to see ponding of water on the arable soils. So the best way to preserve or maintain or improve soil structure is to minimise tillage. If that's not possible, till at the right soil moisture when it's not too wet. To incorporate organic matter, as this has a really beneficial to soil structure, and to keep the soil surface covered. So in summary, soils with a good soil structure and high organic matter content encourage infiltration, whereas soils with a degraded structure, low organic matter content have lower infiltration rates, which can lead to enhanced runoff and increase the risk of flooding. And changes in soil structure can happen quickly. This picture shows soils from continuous arable rotation on the right, and the same soil 3 years after it's been under a grass clover ley as part of a research project at the University of Leeds. So the key message is think about how you can maintain or improve your soil structure if you want to reduce runoff and flood risk downstream. Thank you for listening, and I'm happy to answer any questions later.